All right, welcome back to Mr. PL's with Math. This is Calculus Unit 0, lesson number 4. So we are going to be graphing equations and finding x and y intercepts of given equations. So in this first one, it says solve for y. So we're simply trying to isolate this variable, get it by itself. So you solve this just like you would solve any other equation, but you're trying to get y by itself instead of x by itself. So we have 5y is equal to x plus 12. And then the last thing we would do is divide both sides by 5. And there's my answer. So y equals x plus 12 over 5. For this question, first thing I want to do is I want to get rid, I look at these two, and the first thing I notice is that both of these terms have a y. So the easiest way to do this would be to factor out that y. So y times x cubed is this term, and y times 2 is this term. So once again, if I distribute the y times this and y times that, I end up, that's basically what factoring out the GCF literally is. It's basically just the opposite of distributing. Then I can just divide both sides by x cubed plus 2. Do the same thing over here, and that's going to be my answer. So y is 1 over x cubed plus 2. All right, so over here for this question, I want to solve for y once again, so I want to get rid of everything that's not the y. As a matter of fact, it would probably be easier just to move the y itself since this side's already empty. So that's going to leave me with x squared plus x minus 6 equals y squared. Now I need to do square root of both sides, and that's going to look like that. So y equals, now I look in here and I see that this can be factored, but it's not going to give me a perfect square. So therefore, I really can't get any by factoring it. If it's not a perfect square, it's not going to get rid of the square root. So I'm just going to leave the answer like it is, x squared plus x minus 6. All right, so once again, so we're talking about all these different parent functions. These are all the ones that you did either in Algebra 1 or Algebra 2 or pre-calculus, I guess, when we see sine, cosine, and tangent primarily. And so this is just what they all should look like, so you should be familiar with them. Now, transformations for all these functions pretty much work the same. So if there's plus or minus on the outside, that's going to move it up or down. And if the plus or minus is on the inside of something, then it's going to move it left or right. Now, that, depending on what type of function you're talking about, can be different. So if it's like a logarithmic function and it's inside the parentheses, then it's moving left or right. If it's like e minus something to the x power, then it's going to move left or right as well. But if you just throw a plus 2 at on the outside, that's going to move the whole function up 2. So that will come in handy when we look at one of the problems in the future. It says determine if the points 1, 2, and 1, -1 are on the line. Now, I could set this equal to y, and then it might make it a little bit easier. In fact, I'm going to do that, although I technically don't have to. That's going to leave me with 2x minus 3 on the left, and just y, because when I add y to both sides, 0 plus y is y. Now, the easiest thing to do here is just plug this in for x and this in for y. That's your xy. If it works, then it's on the equation. If it doesn't work, then it's not on the equation. It's either above it or below it, or to the side of it. So simply just going to test each one by putting y in for y. So 2 equals 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is -1, and -1 does not equal 2, so this is not on this equation. So this is a linear equation. So keep in mind, so 2x minus 3, that means you're starting down here at -3. It's going up to right 1, up to right 1. So I know this is just a rough sketch. 1, 2, right 1, up 2 would have been, give or take, about right there. So that's clearly not going to be on the line. It's going to be above the line. 1, -1 does seem like it's going to be on the line. Let's just double check. So to the right 1, down 1, keep in mind that's a rough sketch, so I don't know exactly what the numbers are. So let's throw those in. So -1 was y. 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is -1. And -1 does equal -1. So that once again verifies that, yes, that point is on the graph. All right, sketch the graph. Now, I'm going to do this one very similar to like I just did. This is your y-intercept. This is y equals mx plus b. Now, the b is in front. It's actually b plus mx, but that doesn't really matter because you can just switch it around. No big deal. 7 is our y-intercept. That's where we start, and -3 is our slope. Remember, -3 is a slope, is like down 3, right 1. So -3 over 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And that is what your line is going to look like. Keep in mind it would normally be straight. I'm writing freehand. It's a little hard to make straight lines. All right, so there is our graph. And on the next one, so we have x squared minus 2. Now, if you caught what I said earlier, now keep in mind, regular x squared, as I'm trying to draw here, 1 squared is 1, 2 squared is 4, 3 squared is 9. It makes a parabola shape, so it does the exact same thing on the left and the right, because -1 squared is 1, -2 squared is 4, -3 squared is 9. Now, that would be the parent function of x squared, but we want to find x squared minus 2. So all these points are just translated down 2, because as I mentioned before, this is a k, so you might remember this. So x minus h squared plus k. So this is the transformation. So this moves it left or right, and this moves it up or down. Now this is kind of like x minus 0 squared minus 2, if that makes sense. So there was no h there, so I just put 0 in for h because it didn't move left or right. And you can clearly see that this is a down 2. Now, do keep in mind, and I did not mention this earlier, but for all those parent functions, the h, which is usually inside of something, that's something easy to remember it. In this case, it's inside parentheses, or it could be inside a radical. It could be inside absolute value. The h is always inside something, but it always moves the opposite of what you would think. So if h is a positive, it actually, well, if it's x minus 3, that actually would move right. Minus would move right. And plus would move left. It kind of moves the opposite of what you would think. But if you look at it in just terms of h being positive or negative, then it is exactly what you would think, because it's x minus a positive. Positive means to the right. All right, so find the x and y intercepts, which is the last thing we need to cover. Pretty simple process of simply, if you want to find x-intercept, plug 0 in for y. If you want to find the y-intercept, plug 0 in for x and solve. So if I'm going to find the x-intercept, all I need to do is replace this equation, replace y with 0. So 2x minus 0 minus 3 equals 0. Okay, so -0 minus 3 is -3. If I add 3 to both sides, I get 2x equals 3. And if I divide both sides by 2, it looks like the x-intercept is at 3/2, or 1.5. If I want to find the y-intercept, I will do the exact opposite. I will plug 0 in for x, 2 times 0 minus y minus 3, and then solve for y. 2 times 0 is 0. That basically cancels. So I'm left with -y minus 3 equals 0. Add 3 to both sides. That gives me y equals 3. But keep in mind I need to divide both sides by -1, and therefore y is -3. That is your y-intercept. So once again, a y-intercept is just simply where the function crosses the y-axis, where it hits the y-axis. Now, not all functions are going to have an x and a y-axis. It just kind of depends on what type of function that you are talking about. Find the x and y-intercepts of this cubic function. So same process. If I want to find the x-intercept or the y-intercept, I just simply put 0 in for the other variable and solve. Because essentially when you're looking at a graph, this does make sense. So let's say we're talking about some sort of exponential function. So if this is its y-intercept, that has an x of 0 because it's not to the left or right anything. And this right here, this x-intercept, has a height of 0. So it makes sense that y would be equal to 0 at that point. So x-intercept means we put 0 in for y. So 0 equals x cubed minus 4x. And then if I'm trying to find, well, first of all, I notice that I can factor out the x. And that's going to give me x squared minus 4. And then I know that this can be factored, right? So x times, this is x minus 2 and x plus 2. That's difference of squares. And then I can set each one equal to 0 and solve for each one of those roots. So x is 0. So once again, this is cubic. So x-intercepts, it actually can have, remember, cubics can look like this. It is possible for cubics to have 1, 2, 3 x-intercepts. So we've got x equals 0. If I do x minus 2 equals 0, then obviously that's going to be 2. And if I do x plus 2 equals 0, that's going to be negative 2. So it looks like this function has 3 different x-intercepts. Now, y-intercepts, it should only have 1 always, because if it had 2 y-intercepts, if the graph hits here and here, it's technically no longer a function because, remember, each domain can only have 1 range. It does not pass the vertical line test in that case. So all functions can have multiple x-intercepts, but all functions should only have 1 y-intercept. So put 0 in for x and solve. So y, and this is actually going to be fairly easy. So 0 cubed minus 4 times 0. Well, this kind of all makes sense because 0 cubed is still 0. 0 minus, this is also 0, is 0. So y equals 0, which means it would have hit right here. Now keep in mind, I just made this up, so this was just a possible answer, but it's not actually. All right. And, okay, so I think I got one more. So find the points of the intersection of the graphs. Okay, so when finding where the two, so keep in mind, this is x squared minus 3. So that looks something like this. It's x squared, but it's been moved down 3. And then x minus 1 is down 1, and it looks like this. Now keep in mind, these two graphs are going to hit each other twice, clearly. Now this is, once again, just a rough sketch. What I'm going to do is I'm going to use substitution. If this equals y, then it should also be equal to that y. So I'm going to put x minus 1 equals x squared minus 3. Because they're both y equals. I can, so if y equals this and y also equals this, it's kind of the transitive property, then this, by default, this should also equal this, because they're both equal to y. Now, first thing I want to do is set this up by getting everything on one side. It's quadratic. It's easier to leave the x squared on the right. So I'm going to subtract x from both sides and add 1 to both sides, and that's going to give me 0 equals x squared minus x. Negative 3 plus 1 is negative 2. Now I'm going to ask myself, is this factorable? So I believe it is. So it's x minus 2 times x plus 1, because negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. All right, now, as we talked about earlier, these two are going to hit each other twice, so that's not a shock. X minus 2 is 0, so it looks like it's going to hit once when x is 2, and it's also going to hit when x is negative 1. And that kind of makes sense because this answer is like when x is negative 1, and this answer over here, it looks like it's to the right 2. So our rough sketch does give us some information that makes us feel like we got it correct. All right, and I believe that is it. So thanks again for watching, and I look forward to the next video. Please give it a like if it helped you learn something about how to find x and y intercepts, or maybe about these types of functions. Have a great day.